Okay, today we're going to start out talking about how water is the solvent of life, and then that will lead us into a discussion about pH. So, a solution is a liquid consisting of a uniform mixture of two or more substances. The dissolving agent is the solvent, and then the substance that is dissolved is the solute. And the aqueous solution is one in which water is the solvent. I always think Spanish here, and aqua, water. Okay. So if I have hot cocoa, right, so my dissolving agent is going to be my solvent, so maybe that's my hot water or my hot milk, and then the substance that's dissolving might be the actual hot cocoa mix that I'd be putting together, and then that yummy, yummy hot cocoa that I drink would be the solution that I would be enjoying. As we learned already, water's versatility as a solvent results from the polarity of its molecules. So polar or charged solutes are going to dissolve when water molecules surround them, and that gives us our aqueous solutions. So table salt's an example of a solute that goes into a solution in water, and sugar's another good one. Again, I'm a visual person, so I think this picture is great. So it's showing us how the ions, so chlorine and the sodium ions, so we know that salt is NaCl, and so they're going to pull apart, and the Na here is going to be positive, and the Cl here will be negative, as the drawing shows so clearly and well. And so opposites are going to be attracting, and so if we have here this negative chlorine, well, all these positive hydrogens are going to surround that, and they're going to keep this negative chlorine away from the sodium, so it's going to surround that chlorine. And that's what's going to help everything dissolve, right? Because we're breaking up this whole salt mixture by surrounding all of the ions with water. And so then we see over here in the positive sodium, all of the negative water molecules, the negative side of the water molecules, are now going to surround the sodium. So anything that's polar, this is how it's going to work. The water molecules are going to surround. They will orientate differently depending on what ion they're surrounding, but that's how things are dissolving in water. All right, so now that we know how water can break apart salt and how it dissolves different things in water, now we're going to start talking about how water itself can actually start breaking apart into different ions. So we know that water, H2O, that we see here, so it can actually break apart. If we go this way, it will turn into a hydrogen ion. Okay, so hydrogen ions. And then we also have hydroxide ion, so OH negative. Now this is a great time to talk about chemical equations, all right? So if this is my arrow, if I'm going, maybe we'll change the color. If I'm going in this direction, this side is going to be my reactants. And in this case it's 1, so I have one reactant, and I'm moving this way, and then everything over here are going to be products. I always say the arrow points to the product. Now in this case, this equation is showing us that we can go in the opposite direction. So if I move this way, I'll do blue so you can see it, then that means that this side of the equation then becomes my reactants. And because the arrow is pointing in this way, this direction, then that means that over here are my products. Okay, so anytime you see two arrows, it just means that the reaction can go either way. So always think to yourself, the arrow points to the products. And then, so this is important, you need to know what side are the reactants and what side are the products. Okay? So any substance that's going to donate hydrogen ions to solutions is going to be called an acid. And remember, we show hydrogen ions as a H+, so that plus or the negative sign is just showing that it's an ion. So a base is going to be a substance that reduces the hydrogen ion concentration of a solution, or in other words, it's where we have more, so a base is going to have more hydroxide ions whereas an acid is going to have more hydrogen ions. So we have a pH scale, which is going to describe how acidic or basic a solution is. So it goes from 0 to 14. 0 is the most acidic, 14 is the most basic. Each unit on the scale is going to be a 10-fold change in the concentration of hydrogen ions. And so if we have a pH of a 3 and a pH of 4, it's not just like one difference, it's a 10-fold difference in hydrogen ion concentration, where 3 is going to have 10 times more hydrogen ions than a pH of 4, because the lower we get, things are going to be more acidic, and so that just means that there's even more hydrogen ions. Life is very sensitive to how acidic or basic the conditions around, or even the conditions inside of a particular cell, let's say. And so they need to make sure that there's a pretty even neutral pH system. It can't really swing too acidic or too basic. And so to keep things pretty steady, there are going to be buffers. So those are substances that are going to minimize changes in pH. So they will be accepting hydrogen ions, maybe when there's too many. So when it gets to be too acidic, it'll suck up those extra hydrogens and kind of bring it back to neutral. Or if it's getting too basic and there's not enough hydrogen ions and there's too many OH negatives, hydroxide ions, then it'll start donating those hydrogen ions and kind of bring it back. So again, it's like a teeter-totter. So anytime it sort of swings one way, it'll just make sure that it gets it nice and steady. And buffers are what are going to help do that. It'll help keep things steady. All right, so when we have neutral, you might have heard me say it before, but neutral is going to be a pH of 7. So remember, a pH scale goes from 0 all the way to 14. 7 is going to be neutral, and what that means is that the concentration of hydrogen ions is equal to the concentration of hydroxide ions. The screen here, the wording got a little messed up. So hydroxide ions and hydrogen ions are going to be equal. So the picture here shows everything is equal. And so so on the number scale, if we go below 7, okay, I keep doing that. So if we go below 7, we're going to see that we become more acidic. And why? Because we have more hydrogen ions. Okay. And again, there's a 10-fold difference, so there's 10 times the difference in hydrogen ions between a 3 and a 4, where 3 has 10 times more hydrogen ions than the pH of 4. And so we're acids up here. Okay, and then if we go kind of below here, so if we go in a number that's higher than 7, then we're going to have our bases, and what that means is that we have a higher concentration of OH ions, so hydroxide ions. Okay, so less hydrogen ions and more OHs. Okay, down here, where on the acid scale, there's going to be way more hydrogens. So this will give you a sense, like, of everyday items, maybe that you're familiar with, and next time you're cleaning, you can say, hey, wow, this bleach is going to be pretty basic. Or when you're drinking tomato juice, it's a great conversation starter. Hey, did you ever know it's pH of 4? I'm sure that'll get lots of talk. All right, and here's one example of how pH is going to affect the world around us. So carbon dioxide, the main product of fossil fuel combustion, is increasing in our atmosphere, and they're thinking that that's linked to global climate change. And so about 25% of this human-generated CO2 is absorbed by the vast oceans. The carbon dioxide CO2 dissolved in the seawater is going to lower the pH of the ocean in a process called ocean acidification. So anytime you're going below 7, you're going to have an acid. Okay, so this makes sense. If the pH is going to be lowering, then that's going to be acidification. And so why is that a big deal? Well, as the seawater acidifies, the extra hydrogen ions, because remember, Anytime you have more hydrogen ions, that's what's going to make it an acid. So those extra hydrogen ions are going to combine with carbonate ions, CO3 2 negative, to form bicarbonate ions. And this reaction reduces the carbonate ion concentration available to corals and other shell-building animals. And so that is no good. All right, so I hope that helps with understanding a bit more about pH and how water is such a great solvent. If you have any questions, make sure to ask. And always remember, Jesus loves you.